Welcome to our video lesson. We are on statements, conditionals, and biconditionals, day 2. I feel like this is an accurate picture of how some of us feel maybe with this chapter. I know sometimes this is how I feel after class because what we're doing is challenging, right, folks? It is hard stuff. So just know that you guys are amazing. You are growing that brain of yours, and you are exercising it in ways that you've never done. So be proud and know that it's okay to look like this Mona Lisa here. All right. So we are taking our studies a little bit further today, and we are going to relate our conditionals. So basically, we're going to have a conditional statement, an if then event statement, right? That's conditional, and we are going to switch it up. So the first way we can switch up our conditional is the inverse. Now, an inverse is formed by negating the hypothesis, and conclusion. So in symbols, not P implies not Q. Not P implies not Q. So remember, a normal conditional would be this: P implies Q. Now we're saying not P implies not Q. That is the inverse. Okay. We can do the converse of a conditional, and the converse is formed by switching the hypothesis and conclusion. So we're taking the ending and putting it first, and putting the beginning at the end. So Q implies P. Q implies P. That is the converse. Now lastly, the contrapositive is formed by negating and switching the hypothesis and conclusion. So we're kind of doing 2 for 1. We're switching the order, and we're negating both. So not Q implies not P. All right, let's see what this looks like in action, and maybe it becomes a little bit more sound in your brain. It says, write the inverse, converse, and contrapositive of the following conditional statements. Determine the truth value. If it's false, provide a counter example. So, I promise if you kind of follow my steps, these aren't that terrible. It says, if it is Saturday, then there is no school. So remember, this is our P, it's our hypothesis. And this part over here, there is no school, is our Q. Okay? That is our conditional statement. Now, our inverse, let's look at our little roadmap here, is not P implies not Q. Not P implies not Q. So now, this is what we write. We're going to write not P. So if it is not Saturday, then there is school. So you have to write the not version of Q. So then there is okay. So now we have to decide if this statement is true or false. If it is not Saturday, then there is school. That could be true, but what if it's Sunday, right? So this would be false because it could be Sunday. And you have to write the counterexample. It could be Sunday. All right. Our next one is the converse. Now remember, converse is when you switch the order. So Q implies P. So we're switching the order here. Okay, so we're going to have, if there is no school, then it is Saturday. Now we have to decide if it's true or false. So if there's no school, then we automatically assume it's Saturday. Hope you're thinking false because it could be Sunday. Oops. It could be a holiday. There's kind of a bunch of different counterexamples on this one, but I'm just going to make it easy and say it could be Sunday. We don't have school on Sundays. At least in Grand Forks. Could be Sunday. And then our last one here is the contrapositive. Remember your contrapositive. Use green maybe? Okay. Is not Q implies not P. So we're switching the order and negating them both. So we're going to say if there is school, then it is not Saturday. So if there is a school, then we know it's not Saturday. Is that true or false? This one would be true. I hope you're thinking true. If we don't have school, or if there's school, we for sure know it's not Saturday. In Grand Forks, we don't have school on Saturdays. Okay. This was just to kind of get a taste. We will do more of this together in class. I just kind of wanted to get one example under your belt before we kind of dive into this more. Thanks for watching. See you later. Bye.